Hey guys, welcome to the lesson. I'll try to keep this short, but we're going to introduce something a little new to you. And we're going to be looking at something which we call like terms. Now, like terms, we've actually talked a little bit about already, but I just didn't refer to them. But we've talked about terms and how terms are groups of numbers. So what like terms are groups of numbers that are obviously alike. They're similar. We can combine them together. This is like saying that if I have three apples, one there, and one there, and then I have another four apples over here, why would I keep them separate? Why wouldn't I just put them all together so I have all seven apples in just one place here? So we don't have this separation between the two groups. And so that's what we're going to be doing with like terms. We're going to try to see how we can apply that to the things that we were doing the other day with our different terms and monomials and binomials, and look at it from there. So let's get into this. Make sure that you have a pen and pencil ready and that you have everything, that you're going to copy everything that I write down with you. So what a like term is, these are groups of numbers. So like terms are groups of numbers that have the same, well, now these two things. They have the same variables and they have the same exponent. They have to have the same variables and the same exponents for them to be like terms, for them to be able to be combined together. For example, if I have something like this, let's say I have 4 and I have 6 and I have 2. Well, those are all numbers. So we know that numbers are common, and if we wanted to group those numbers together, we would just say, well, okay, well, if I have 4, I can combine that to 6 and I can add that to 2, and that's going to give me 12 altogether. And so I can combine those terms. Likewise, if I had something like this, well, 3a and I have 5a. Well, that's like saying I have 3 apples and I have 5 apples. I won't keep them in two groups. I'll put those together. And so I'll just go 3a plus 5a is equal to, well, I have 3a's there, 5a's there. I'm going to have 8a's all together. And that's what we mean by like terms, groups of numbers that we can put together. Similarly, if we have something like this and we have 6a squared and we have negative 2a squared, there's the same variables, same exponents. I can just say, well, look, those are the same group. So I'm going to put them together as long as they meet this criteria. Here, numbers, they have the same variables and exponents. They don't have any of them. So we can easily put those together. But we have an a squared here, an a squared there. If I have 6a squareds here, but I'm losing 2a squareds there, what I can do is this, and I have 6a squared plus negative 2a squared. That'll just give me my 4a squareds all together at the end. So when we're combining like terms, what we want to be able to do is just group things that are common together. Now what I cannot do, I can't do this. I can't say I'm going to take a 3a and add it to a 4a squared, because they're just not the same. These are a's, these are a squareds. They're mathematically not identical. And so I can say, well, look, I have 3a's here and I have 4a squareds there, but I can't combine. So these ones just are not possible, okay? We just can't do it, and so we leave them separate. But a lot of the other ones we can combine together. So let's look at an example about what something like that would look like. If I asked you, or the textbooks asked you, to combine like terms, what would that be? So let's just start sort of a new page. If you have a new area, we'll go from there. And let's do this. So we'll look at, that one's not working, combining like terms. And so what we're going to do is we're just going to find anything that's in common here that we can do. that says combing. Combine effort combining. We'll just imagine that was up there. All right, so yeah, it's not professional quality here, kids. So if we got something that looked like this, we'll start off easy. We'll say we had 4a plus 3 minus 2a plus 4. And we'll start there and we'll say, okay, well, what is common to these ones? And we'll say, well, here we have a 4a. And over here, we have a negative 2a. Now, one thing that I should keep in mind, and one big hint for these, is always get rid of subtraction. We've been doing this from day one, is we never work in subtraction. So really, when this is minus 2a, this is going to be plus negative 2a. And so you don't have to do this. My next step, I'd like you to write it down, but normally we wouldn't do this, and we'd say, well, this is 4a plus negative 2a's, and I'm going to rewrite this in group. Now, normally we should be able to see this. Now, then I'll take my 3's, and I'll say, well, what's in common with my 3? Obviously another number, which is going to be 4. And I have my a's together and my numbers together, and now I'm just going to gather them up. If I have 4a's here, and I have negative 2a's there, that means that I have 2a's. And lastly, if I look at my numbers, I have 3 and 4. 3 and 4 is going to give me a total of 7. And all of a sudden, that 4 terms I can simplify down into a binomial here. And you'll notice the terms are now different. The variable is in here. This one doesn't have a variable. And we reduced this down, or simplified it down to 2a plus 7. Okay, and that's what we're doing with like terms. What can we gather together? So if we make this a little bit harder now, we may get something that looks like this, where we'll have 3a squared minus 2a plus 6 plus 5a minus a squared plus 3. So we have 3a squared minus 2a plus 6 plus 5a minus a squared plus 3. So let's do our first step, get rid of subtraction. This is plus negative 2a. This is plus negative. Now the negative's got to go with something. So the negative has to go with the number. So we're going to put a 1 in front there because we have a 1a squared. And then we'll have 3. Now what we're going to do is we're going to go through and we're going to gather what we can. So we'll start with the 3a squared. And we'll say, well, what's common to this? So we're looking for the same variable, same exponent. Same variable, but not the same exponent. No variable, variable, but no exponent. But down here, we have our other a squared. So 3a squared and a negative 1a squared is going to give us our 2a squared. And then we'll go to the next. And we'll say, well, here is negative 2a. Do we have anything else that has an a in it? Okay, that one doesn't, but this one sure does. So we'll do that just to give us a reminder. And then there's our number. And so we have negative 2a plus 5a, and that'll give us 3a's all together. And lastly, we have our 6, and we have our 3. And 6 and 3 is going to give us our total of 9. Now you'll notice that when we look at our final answer, what we end up getting here is we end up with a trinomial. And the reason why is because we have 3 distinct groups. A squared, a, and then our constant or our number at the very end. And that's why we break them into groups or our terms, and we gather up things that are common. So here's what I want you to do. I'm going to write 2 here on the board. I want you to try these 2. Then what I want you to do is I'm going to pause the video, or we'll get the teacher to pause the video, give you a minute to try these 2 out, and then let's check the answer. So here's the one that I want you to do here. And the first one is actually going to be pretty well reasonable, but the next one will be a little bit tougher. So we have 4a minus 3a plus 2 minus 5a plus 6. So we have some variables with some solid numbers. Get rid of your exponents or get rid of your subtraction, work in negatives and positives only, and then combine together. The second one that we'll do then will be this here. So we'll have 3a squared plus 4a minus 2ab plus 6b minus 4a squared plus 3ab. Okay, so I want you to try those two out, pause the video, and in a couple of minutes we'll come back and we'll see how we did. Okay, good luck. Alright, so let's try these two out. We're going to get rid of our subtraction. This is plus -3, this is plus -5, and we're going to see what we can group together. Okay, there is our 4a. We'll see, oh, there's another a. There's a number, and then there's one more a. So we'll notice that we have 3 groups, all with the same variable. 4 and 3 gives us 7. 7 and -5 will give us 2 a's. We look for our next group. We have 2, we have 6. So 2 and 6 is going to give us a total of 8. And there is our simplified form of that. So we went from 5 terms all the way down to 2 just by combining our like terms together, looking for ones that have the same variable and the same exponent or just a number. If we look at our last one here, what we end up getting is a little bit longer one, but it's sort of the same thing. So don't panic at the size, just take it slow, do it in pieces. There's plus -2a, there's plus -4a squared, and then everything else should be good. We'll start at the beginning. We have 3a squared, and there's just an a. There's an ab, well that's a little different. We have 6b, but then we have this 4a squared here, and then we have the 3ab at the end. When we look at those two, 3a squared and -4a squared, well 3 and -4 gives us -1, and that'll be -1a squared. We look at our numbers again, and we'll now go to our a's, and we say, well, is there any other ones with a in it? And we'll notice that none of them have a. And so the next one will just be 4a. We go to the next one here. Okay, there's a -2ab. Well, that's just a 6b. It's not the same variables, but 3ab will have the same variables. We have -2 here, 3 here. -2 and 3 will give us 1, so we'll have 1ab. And then at the very end, the only thing we're left with is that 6b, and we have no other terms or nothing else that we can combine together. Hopefully you got those two right. If not, hopefully what you saw was how to do it correctly or where you made your mistakes. All right, there's some questions for you guys to do on this. Good luck, and it is all due for Monday.